Hello? Hello, hello, hello?
This is a special NASA Edge quadruple Doppler weather update on the 4s. 70 degrees and sunny. 99% chance of rain. Wind chill factors. Sleet turning to snow. Smog alerts. Solar storms. Bob Dylan saying you don't need a weatherman to know which way the wind blows. But we all want weather data. And we get it aplenty from NOAA's Geostationary Operational Environmental Satellite System. GOES has provided persistent observation of the Western Hemisphere for over 30 years, and GOES-T is the third satellite in the designed to continue this profound observational data with even greater clarity. Like our other national treasure, Mr. T, GOES-T is outfitted with an abundance of hardware. GOES-T's suite of instruments provide terrestrial data and data related to space weather. I'm looking at you, magnetospherians. And not only helps scientists speak to localized and specific weather patterns, but also provides a unique look at natural disasters and atmospheric phenomenon. Sophisticated, loaded with instruments, NOAA continues their tradition of exceptional environmental and weather observation with GOES-T, making us a weather-ready nation. Welcome to NASA Edge, and we're looking live at Space Launch Complex 41, and it looks to be a beautiful day at the Cape Canaveral Space Force Station. Later in the show, Franklin Fitzgerald and Mick Woltman of the Launch Services Program will cover the rollout of the GOES-T satellite atop ULA's Atlas V rocket. But now, joining me in the high bay of Hangar AE is Pam Sullivan of NOAA. Pam, thanks so much for being on the show.
Oh, it's great to be here. Thanks for having us.
Well, I have to tell you, exactly 4 years to the day tomorrow, you were on our GOES-S launch show, and here we are now, GOES-T, and you're no longer with Flight Projects. You're a system program director. So tell us a little bit about what your new responsibilities involve.
Right. Well, for GOES-S, I got to be the go for the mission to say the satellite was ready to launch. So I like to say that's when I had a real job. Now I'm more program management, and I now have responsibility not just for the flight elements of the satellite and the instruments, but also the ground system, our operations. So kind of the whole GOES-R program. But mostly what my job is making sure that the people that are doing the real work have what they need to do the real work, and they're talking to each other. And anyway, so that's my job, is really just to coordinate the whole team.
Awesome, awesome. Well, you know, GOES-T is a very important mission. GOES is a very important mission for NOAA. So how does it sort of fit into the whole overarching NOAA mission?
Yeah, NOAA has many different satellites. The geostationary ones are kind of the ones that are most important for watching dangerous conditions as they happen, things like hurricanes and tornadoes and fires. And so the GOES-R series give you the up-to-the-minute data. Some of NOAA's other satellites, like our polar orbiting satellites, give you data that go into numerical weather models, so that you can, so that our forecasters can do like the 5-day out, the 10-day out forecasts. And then we have other satellites we're developing right now that will go out to Lagrange points, which are good places to, if you're looking at what the sun is doing and what the space weather environment is like. So those are the kind of the three missions that we have: the geo, the polar, and the space weather.
Man, that's a lot of stuff. That's very impressive. And not only that, I mean, you think of the GOES series, this is the third of 4. U is right around the corner when you guys will launch that. So do you have any updates on GOES-U?
Oh, yeah. GOES-U is doing really great right now. The team actually is focused on GOES-T, as you can imagine.
Sure.
But as soon as the launch is done, the team will go back to the Lockheed Martin facility in Denver, and they will start taking GOES-U through its environmental tests. So 6 of the instruments have already been delivered and integrated. We're just waiting for one more. But later this summer, we'll start the environmental test program for GOES-U.
That is awesome. Now, when the entire GOES-R series is flying, obviously it's supposed to get data for some incredible length of time, like in the 2030s, right?
Yeah, absolutely. We build the spacecraft to last 10 years, and so GOES-T and GOES-U are projected to operate into the 2030s. But that doesn't mean that we get to relax after we launch GOES-U. We're actually already working on the thing that will follow the GOES-R series, and which we're calling GeoXO. So these are satellites that will launch in the 2030s, and they'll actually operate into the 2050s.
Whoa. I mean, I want to be optimistic, but it's hard to think of missions that might extend even beyond what we're doing here. That's incredible.
Well, you can never. It's important to never run out of weather satellites. So that's the planning that we're doing right now to make sure that there's something that follows GOES-R.
Now, today we're looking at the rollout. Tomorrow's the launch, and obviously you've been working with GOES for a long time. Tell me a little bit about what it means to see this satellite launch and actually move into operational space.
Yeah, I always say the launches are kind of an interesting feeling. For the engineering team, it's the end of things, but for the scientists and the forecasters, it's really the start of things. And so it's a really interesting transition, and it gets to be a big event as well. So it's exciting. It's exciting both for the ending and the starting.
Well, we're so excited. Hopefully, Pam, you will be available and will be available to cover the GOES-U launch when that happens in a couple of years. But until then, we wish you the best of a launch and keep up the good work. Thanks for being on the show.
Oh, thanks, and GOES-T.
Yeah, absolutely. Franklin had a chance earlier to sit down with another GOES-R team member, Ed Grigsby. Franklin?
Thanks, guys. I'm here with Ed Grigsby, who is the GOES Deputy System Program Director. How you doing today?
I'm doing great, Franklin. Nice to see you.
Nice to see you as well. Ed, can you tell us about NASA's role in NOAA's mission?
Oh, absolutely, absolutely. NASA and NOAA have enjoyed a harmonious relationship for almost 47 years now in the GOES program development. The mission of the GOES series has always been a very good partnership between NASA and NOAA. And NASA's role has been to manage the development of the spacecraft, all the instruments, and launch vehicle, and get this launched and commissioned.
Now, as in your role that you have now, do you work with the vendors that work on the spacecraft and deliver the instruments?
The system program director and I work with our flight project and our ground project to oversee all of the vendor development. So we watch how the vendors are developing. We manage all of the projects work with the vendors. So yes, we do.
Can you tell us a little bit about the instruments that are going to be on GOES-T?
Oh, sure. Like GOES-R and the GOES-S, GOES-T will have 6 instruments. There's the Advanced Baseline Imager, which takes images for the weather forecast. The Geostationary Lightning Mapper, which captures lightning strikes. The SUVI, which is a solar ultraviolet imager. It captures images of the sun. There's EXIS, which is an extreme ultraviolet and X-ray irradiance sensor. It captures solar information as well. There's SICE, which is a solar environment in situ sensor suite. It captures galactic protons and galactic electrons and all of the energy, the high particle energy and low particle energy.
Space weather stuff.
Space weather stuff.
All right.
And then there's the magnetometer, which is a Goddard Space Flight Center developed magnetometer that measures the very minute magnetic field changes that are at geostationary orbit.
So when I'm looking at my local news in Virginia, during the weather broadcast, they said we have lightning strikes in this area, and they have the little light. Does that come from the GOES satellites? Is giving that information? Is that the only satellite that gives lightning strike?
So there's a ground network that provides location of lightning strikes, and I think there's still an instrument on ISS that provides information, but consistently, temporally, the geostationary satellite can view lightning strikes constantly. The ISS has an orbit that does not allow it to view constantly. The ground cannot image where those are. It can only determine electromagnetic radiation direction by angle of attack. So the persistence of vision of the GLM from geostationary gives you persistence of location and intensity.
Ed, I asked about the lightning because recently there was a phenomenon where a lightning strike stretched partway across the United States.
Oh yeah, the mega flash. That's incredible. It was 470 some odd miles across the southeast. It's really interesting. This is the first time that they validated the existence of mega flashes, and GLM data helped validate that those exist. Scientists had seen them before, but now we know they exist.
Ed, thanks for being on the show today.
Franklin, very, very pleasurable.
Again, we're looking live at Space Launch Complex 41, actually the vehicle integration facility at this point. You can see the Atlas V. It is ready to roll out. The rollout has not begun. We'll get an update from Franklin and Mick later in the show. But joining us again in Hangar AE is Dan Lindsey, the chief scientist for GOES. Dan, thanks for being on the show.
Thank you so much for having me.
I got to tell you, I'm super excited to hear about what Ed had mentioned in the interview with Franklin, this mega flash that was captured by the GOES satellites and validated this as a scientific principle. Can you tell us a little bit about that?
Sure. So we have an instrument on the GOES-R series called the Geostationary Lightning Mapper, or GLM. It was first launched with GOES 16 back in 2016, and then we also have one on GOES 17 in the west position. This instrument is able to detect optical energy from space, and so it keeps a constant watch on storms. And therefore, when you get one of these big flashes, like the one that you mentioned, we're able to understand the horizontal extent. And that's not something that you can do from other types of instruments. And so it was really exciting to be able to collect this data and then officially document the record-breaking size of the lightning flash.
And I would imagine that that's really part of what the science team did for GOES. They knew they needed a way to sort of record this kind of event, and that's why it was put on GOES originally, right?
Yeah, there's a number of different applications. It also provides additional information for severe storm warnings. Radar is the primary tool for issuing warnings, but when you get information about lightning, sometimes you get lightning flash amounts will increase prior to the storm becoming more strong or severe. And so forecasters can use that extra information to make a decision. Do you issue a warning? Do you not issue a warning?
And I've seen those warnings, and I'm very thankful for them. So good job, GOES, right?
Absolutely.
Now, can you tell me a little bit about the other instruments? Because I understand all the GOES spacecraft fly with a lot of really important instruments.
So in addition to the Geostationary Lightning Mapper, the other Earth-pointing instrument that we consider really our primary instrument is called the Advanced Baseline Imager, or the ABI. That's the instrument that takes the movies of hurricanes and the clouds, and we can watch the hurricanes spin. It also is able to detect wildfires and the smoke from the wildfires. It really has a wide range of weather applications. In addition to that, we have a number of instruments that are designed for space weather. Those include, we have a magnetometer that measures the magnetic field around the Earth. We have something called SUVI. It looks at the sun and takes pictures in the ultraviolet, and we're able to use that data to detect things like coronal mass ejections and solar flares. We have something called EXIS. It sort of measures the overall energy output from the sun. And then the last one is an instrument called SEIS, and that one measures particle flux coming from the sun to the Earth.
Now, it's interesting that there's so many instruments related to space weather, because for me it seems like a relatively recent phenomenon, but GOES has been working on this for years. Why is space weather so important?
So space weather, it's been monitored for many years, like you say. We are currently coming out of what's called a solar minimum, and that means when the sun is relatively less active. That was in 2020 or so. And we're ramping up toward the next expected solar maximum, which happens in 2025. And what that means is when you get closer to solar maximum, you have a higher likelihood of having these space weather storms or solar flares, coronal mass ejections. So we use the data from the GOES satellites to keep an eye on the sun and get an idea when those things occur. When the charged particles make their way to the Earth, they can cause disruptions to things like communications. They could even cause electrical blackouts, and they can affect even satellites themselves. So it's really important that we keep a constant watch on those solar storms.
What I think is fascinating about NOAA's approach here is that not only are you providing information that's helpful for people on the ground, but obviously that's helpful for anyone, for astronauts maybe in the ISS, but anywhere traveling in space.
That's right. Yeah, astronauts. There's literally thousands of satellites out there now, and so the satellite operators need to know when these events are happening, so they can sometimes take precautions, go into safe mode, that kind of thing, to try to protect their precious equipment from these solar storms.
Now, I have a question for you, Dan, because you're chief scientist, and I'm wondering, what's a day in the life like for a chief scientist? Do you sit around and analyze data all the time? Because it's a lot of data coming down.
Yeah, to be honest, I wish I had the time to analyze the data all the time. Most scientists, yes, that's exactly what they're doing, is working with the data as it comes in. From GOES-T's perspective, my job really doesn't begin until the data begins flowing from the satellite back to the Earth. And that's not going to happen for a few more weeks at the minimum. We have to wait for GOES-T to make it to geostationary orbit, when it will become GOES-18. And then we have to power on each of the instruments one by one, and then they begin sending back the data that we use to, to calibrate the instrument, and then, check it out, make sure that everything looks the way it's supposed to look.
And one final question. This is for me personally. I mean, I'm just wondering this. Have you ever met a scientist, or have you ever said, this is too much data?
Absolutely not. We can never have enough data. It is a tremendous amount of data. From the ABI alone, we have 60 times more data than the previous GOES imager. So we had to prepare for the data, bigger hard drives, more bandwidth, et cetera. But in terms of the data itself, we'll take as much as we can get. We can use that to expand on our applications.
That's awesome. I'm so excited. And thanks so much for being on the show. We look forward to you getting lots of data that you can't handle.
Thank you so much for having me. I'm excited to be here.
Awesome. Franklin also had a chance earlier to speak with Candace Carlisle about how the spacecraft was ready to come to the Cape. Franklin?
Thanks, guys. I'm joined today on the set by Candace Carlisle, who is the GOES-R Flight Project Manager. How are you doing today, Candace?
I'm doing great, and I'm really excited about the GOES-T launch.
Oh, we are absolutely all excited about the GOES-T launch. Now, as the GOES-R Flight Project Manager, and you're associated with GOES-T, can you tell our audience the difference between the two?
The GOES-R series is R, S, T, and U. GOES-R and S are already on orbit as GOES-16 and 17 in the east and west position. GOES-T is the next one up. It will be moving into the GOES-West position, and there it will be called GOES-18.
As the Flight Project Manager, can you tell us a little bit about your responsibilities?
The GOES-R Flight Project is responsible for the spacecraft and all the instruments. We also work with the Kennedy Space Center to ensure a successful launch. And our mission operations support team works with NOAA to check out the spacecraft and then provide engineering support throughout their lifetime.
Now, with this GOES-T satellite, I understand there was some upgrades and a new magnetometer was developed for this upcoming flight?
Yes, for GOES-T, the team replaced the radiator on the Advanced Baseline Imager instrument, and also changed out some electronics on the Geostationary Lightning Mapper instrument to provide improved reliability. And thirdly, there's a completely new magnetometer that will be flown on GOES-T and GOES-U that was built right here at Goddard Space Flight Center.
Now, with the new magnetometer, was the environmental testing done here at Goddard?
Yes, the GOES-T magnetometer was completely checked out here at Goddard, as are all of the instruments before they're delivered to the spacecraft. They're all checked out at their vendor facility. For the GOES magnetometer, that involved using all of our special test facilities here at Goddard. We have our own thermal vacuum chambers, we have our own vibration testing, and we also have a facility for checking out magnetometers that will null the Earth's field so that they can check out and make sure their functionality. For the Advanced Baseline Imager instrument, the radiator was built at Northrop Grumman in Beltsville, so it was completely checked out there by that vendor, then delivered to the ABI team, L3 Harris, and it was integrated with the sensor unit and checked out in their Rochester, New York facility. Then everything is sent to the spacecraft, and the spacecraft completely undergoes environmental testing at Lockheed Martin's Littleton, Colorado facility. The spacecraft was shipped to Kennedy in November, and there the team completely checks that out to make sure it arrives safely. Then it goes forward into a flow with the launch vehicle, where first it's mated to the attachment and then the fairings put over it, and then it moves to the vertical integration facility where it's actually mated with the rocket.
That all sounds absolutely amazing. Where are you going to be during the launch?
During the launch, I will be on console at Kennedy Space Center with the whole team from Kennedy and from Lockheed Martin and, of course, from Goddard, making sure that everything, and ULA, of course, making sure that everything is okay and ready to go.
Well, thank you, Candace. We definitely looking forward to a successful launch and getting good data and images from GOES-T.
Thank you. We can't wait to see GOES-T on orbit and all of the great data it's going to provide.
Live from the Space Launch Complex 41. Looks like the roll is very close to beginning. We're going to go now live to Franklin and Mick, who will give us the update from the ground, although it's a little bit of a distance for them to get from where they are, but they've got all the answers.
Mick, the roll has begun.
Yeah, Franklin, the team has been working very hard this morning to make sure the rocket's ready. The mobile launch platform was configured properly, and they have begun rollout. They're coming out of the vertical integration facility and beginning that 1,800-foot trip down to Space Launch Complex 41.
Now, we're a little behind schedule. You know, before the roll started, you talked about a poll that had to take place. Can you tell us a little bit about that?
Yeah, so the test conductor this morning, just prior to the roll, they want to make sure everything's configured, everything is transferred over to generator power, all pressures and accumulators, environmental control system is transferred. And so the test conductor does a poll with his team to make sure all those systems are in place, ready to go so they can do the poll. That poll happened about 7 minutes ago, so they were a little bit behind schedule from the normal roll schedule, but that's not bad for the team. They did a great job this morning, and as I said, we're rolling now and getting things moving.
Now, when you talk about transfer, you're talking about power from the VIF to the mobile launch platform?
Yes, sir. When we're in the VIF, we're on what we call ground power, hooked to the facility power at the vertical integration facility. We need to put some of that on generator power, and then also some of that, like the environmental control system, on the portable ECS that's following the mobile launch platform out to the pad. Once they get the rocket to the pad on the mobile launch platform, they'll reconnect all that to facility power. So for that trip, we got to make sure everything's still working, make sure we take care of GOES-T.
Okay. Now, the mobile launch platform that I can see that is hooked to the Atlas V, it is also connected to, it looks like a train. Can you tell us a little bit about that?
Yeah, so the way the mobile launch platform works is in front of the mobile launch platform we have what we call the P-van and the G-van, and those are the areas where the spacecraft have their racks to communicate and talk to the spacecraft, and then also the rocket telemetry and be able to talk to the rocket that the launch team can do. Behind the mobile launch platform, we have the ECS, the environmental control system, and along with some tugs that are pushing the MLP up the track. So the Atlas V on the mobile launch platform travels little less than about a half a mile an hour on railroad tracks all the way to Space Launch Complex 41.
And you said that is an 1,800-foot?
Approximately 1,800-foot trip from the VIF to the pad.
Okay, sounds good. You can hear the what's the noise that we hear?
So you're hearing a combination of those trucks that are pushing the MLP and a combination of the environmental control system, air conditioning, and all that working right now. And I will tell you right now, where we're standing, it's a beautiful sight to see that Atlas V and MLP rolling, but they're probably about 1,500 feet from us right now, so we hear that sound, but wait till it gets a little closer. It'll be incredible to hear that Atlas V. Yeah.
Yes. Fast forward to tomorrow. Launch time. How's it looking for weather, for launch conditions?
So launch weather officer this morning from the Space Force sent out their updated weather forecast, and they have reduced our probability of violation from 40% to 30%. So that's a good thing for us. That means we have a 70% chance of launching tomorrow at 4:38 p.m., the beginning of our 2-hour window. We have a couple things that we're looking at. As you know, here in Florida right now it's a little warm, but tomorrow weather's going to start cooling down. We've got a cold front coming in, and there's some things we need to worry about in the upper level winds and also electrification in the atmosphere. So we'll be keeping an eye on those, but like I said, I'm very happy with that 70% go for tomorrow.
That sounds great. You know, today there's a forecast of rain later on in the afternoon. Could something like rain cause a delay in a launch?
So it depends, honestly. Typically not, but it would depend on what's going on around with that weather system. If we have lightning in that weather system, which of course being here in Florida, the lightning capital of the world, that is something that could stop our launch. If there's upper level wind problems, that could stop our launch. Cumulus cloud level problems could stop our launch. So it's a combination of the weather, not just the rain. The vehicle is actually built to withstand some rain, and analysis have been done to look at erosion components and things like that. So rain by itself, no, but the combination of that weather, we got to keep an eye on that to make sure GOES-T is safely launched.
Yeah, and you mentioned lightning. I'm not sure if we can get a shot of the pad, but there are these structures that surround the launch pad that have these white columns on top, and I understand they have something to do with lightning.
Yeah, they're what we call our catenary tower system. It surrounds the pad. These two towers on both sides of the pad, 180 degrees from each other, have a catenary wire system that runs across the top of them. That during a lightning storm, the idea is this catenary system would take the lightning and diffuse the lightning to the ground. That way we as a launch team, along with our commercial partner, United Launch Alliance, can then do some analysis and figure out, do we need to retest anything? Is there an issue with the rocket? Or can we just continue to move on? So it provides us a lot of data to be able to make that decision prior to launching. So luckily right now we have no lightning in the forecast, so I'm happy, but these catenary towers are there for our protection.
Yeah. I don't know if our viewers can see, but there's a windsock looks like it might be about 500 feet or so in front of the mobile launch platform. Does that have any bearing on what takes place during the rollout?
Yeah, absolutely. So wind is a big thing we got to worry about. You know, the rocket is sitting on the mobile launch platform held down with some explosive bolts, and so we have wind constraints that from whatever direction before we can determine if we roll. So that was part of that poll this morning, Franklin, that the launch weather officer was part of that poll also, to determine that the forecasted winds over the next hour or the 30 minutes of the roll plus some margin were coming out of the right direction and were below our wind limits on the vehicle. We don't want to do anything that would upset the Atlas V, tip it, do anything like that, put some wind strengths on it. So we do have that wind requirement to make sure that we transport safely.
Now, once the mobile launch platform reaches the pad, are there any, incidents that might take place that, the launch vehicle is actually rolled back to the VIF? Can that actually happen?
So we've had that happen over the years, typically around a hurricane time. We want to make sure that we're protecting the launch vehicle, so we roll it back to the VIF and put it in safe haven is what we call. But for the most part, the launch vehicle will stay at the pad. It can withstand a lot of weather, a lot of wind once we hook up some systems at the pad. But that is monitored 24/7 once the vehicle reaches the pad by the United Launch Alliance team in their launch control center. So those decisions would be talked about with management prior to it happening. But for the most part, we'll stay there and be ready for launch. But there are circumstances that there will have to be some discussions occasionally. Like I said, typically hurricanes.
Now, you said the launch window is 2 hours. How many days can the launch vehicle stay at the pad before it has to be rolled back?
Launch vehicle can stay at the pad quite a few days, actually many days. The constraint we have is launch availability from the range and the resources of the launch team to make sure we're not overworking our launch team. So the vehicle itself could stay there as long as we want.
Okay. Well, guys, we're coming to the end of our show. The mobile launch platform is coming down the track. I want you all to go ahead and join Mick tomorrow with Daryl Nail on coverage on NASA TV. We're starting around
4 o'clock.
Around 4 o'clock. So make sure you tune in to NASA TV tomorrow to see Mick in the launch of GOES-T. From Slick 41, I'm Franklin Fitzgerald for NASA Edge. You're watching NASA Edge, an inside and outside look at all things NASA.
vertical integration facility. They'll pick up a little bit of speed to about a half mile an hour, which takes about 30 minutes for them to travel from the vertical integration facility down to the launch pad.
Now, you said they were on the mobile platform was on an incline right now?
So, yeah, the vertical integration facility actually sits just a little bit lower in elevation than the launch pad. So what has to happen is when they come out of the vertical integration facility, or the VIF, they come up this slight incline on the road, on the railroad tracks, and then when they get to the ramp here at the pad, things tend to level out, and then they can get into the pad.
Talk about this crew of people that surround the mobile launch platform and the Atlas V as it rolls toward the pad.
Yeah, so we have a lot of folks, not only the technicians and mechanics that are working the vehicle, but there's also some management team and all that are out there for looking at the vehicle along with the GOES-T customer. But for the workforce that's out there, that team is following along to make sure that the P-VAN, G-VAN generators, the environmental control system, and all that stuff we talked about that's moving that mobile launch platform continues to keep working and just checking out things to make sure nothing is going wrong.
Now, the Atlas V 541 configuration is slightly different from the launch of GOES-S. Can you tell us a little bit about that?
Yeah, so GOES-S launched on a 541 also, but the GOES-T mission being the Atlas V 541, the one difference on this vehicle versus that one is we are flying the new GEM 63 solid rocket boosters. The GEM 63s are an upgraded manufacturing process and some work that was done. Those are those 4 white solid rocket boosters we see on the first stage. We are excited to be flying those. The ULA and Northrop Grumman have done a great job of getting these new solid rocket boosters manufactured and in place. And we're looking forward to using those to launch GOES-T this morning, along with the thrust of the RD-180 at liftoff. We should be around 2 million pounds of power coming off the pad.
Oh man, that is going to be great. Hey Ron, I hear myself. Now let's fast forward past the Atlas V here. I was talking to you earlier about the VIF and the Vulcan that is coming down the pipe here. Can you tell us a little about the next generation for ULA?
Yeah, so United Launch Alliance is a great commercial partner with LSP. You know, we have had an awesome partnership with them for a lot of NOAA satellites, and launching GOES-T is just the next one. But down the road in the future, we are working with United Launch Alliance on their next vehicle, their Vulcan Centaur. And they are in process of putting that together right now, manufacturing that and testing it out. And we look forward to working with them on that. And, of course, to do that, they have to make some modifications at the vertical integration facility and out here at Slick 41 to accommodate that new vehicle. And so the team will be working between launches. They are modifying decks, modifying the building, modifying the pad to accommodate that new launch vehicle that they're excited to be launching.
Now, you said Vulcan Centaur. Is the Centaur rocket going to be slightly different than the ones that have been used, say, for instance, here with the Atlas V?
It'll be a slightly larger version that they're developing, but the same technology that has performed very well for United Launch Alliance, that high-energy Centaur engine. But they will enlarge some tanks, make some other modifications, and get that RL-10 that we fly now upgraded to a new version. And they'll be able to use that Vulcan, that Centaur, to help deploy future satellites in space.
Now, with the mobile launch platform, when it gets up here to the launch pad, how are all the power, how is everything routed at that point? Is it unhooked from, you may have told me this a little earlier, but is it unhooked from the mobile launch platform and then hooked up into the pad itself?
Yeah, so the vehicle is moving on the mobile launch platform now, as we talked earlier. It's got the P-VAN and the G-VAN in front of it, which are on generator power, providing information to, monitoring information from the spacecraft and the launch vehicle, providing power to the vehicle right now. As they get to the Launch Complex 41, those vans actually will deploy inside what we call a bat cave. It's like a little cave inside the pad there. So they're protected during launch, but things are transferred over to facility power at the pad so that everything is working and the team can monitor that from the Launch Control Center.
Now, you talk about a cave. I've walked up and around the launch pad, and there is a massive cave or opening under the pad. Can you tell us about that opening and what it's used for?
Yeah, that's actually what we refer to as the flame bucket, and that is where all the exhaust from the solid rocket motors and the RD-180 are put into. So once we ignite those engines, the solid rocket boosters, all the thrust exhaust goes into the flame bucket and is diverted away from the pad. As part of the system, we have the water system, or water birds, that are around the pad, and United Launch Alliance will dump thousands of gallons per minute into that flame bucket just prior to ignition. And then once the engines ignite, they will basically flash steam that water, which is what we see coming out of the flame bucket. And the reason we do that is to reduce the acoustic levels on the rocket, because once you ignite the solid rocket boosters and the RD-180, there's an acoustic wave that would go down in the flame bucket and come back on the vehicle, and that water helps reduce that so we can protect GOES-T and the launch vehicle.
Now, there are a lot of cables that surround the launch vehicle on the pad. Are those destroyed during launch, or are any of those salvageable after launch?
So a lot of them are not. We refer to those as burn-off cables. They're one-time use per mission. The team does try to protect them as best we can by using a RTV over the top of them. However, after you ignite 4 solid rocket boosters and an RD-180 and that thing lifts off from Launch Complex 41, there's a lot of damage that occurs on the MLP deck, and those cables are pretty much, as I said, burnt off. So what the team does is they maintain an inventory of those standard cables, and between each mission, there's a team that comes out and replaces those burn-off cables between each mission, and then they verify their systems are working with the new cables.
After the launch, how long does it take for the crews to access the launch pad?
So the team, United Launch Alliance, right after GOES-T launches, about 30 minutes after launch, there'll be a small team that comes in and secures the pad, makes sure everything looks good, make sure there's nothing flailing around or damage that would cause personnel safety issues. Once that's done, then United Launch Alliance sends their mechanics and electrician team in, and they secure the pad and get it ready. And then over the next couple days, they will begin modifying the pad, getting things ready, getting the mobile launch platform back to the vertical integration facility for their next mission.
Sounds great. Now, just to the right of us, walking in front of the mobile launch platform, is a group of I'd say about 20 people. They're just taking a casual stroll.
Yeah, so this is United Launch Alliance management, Gary Wentz and John Crocker. They are taking the spacecraft customer along to show them what's happening here at the pad. It's kind of a last chance for the spacecraft customer, GOES-T, and the ULA management team to see what's happening on rollout. It's kind of a special occasion to be able to get out here and see that. As you and I are standing here, we see that mighty rocket heading our way right now, and that's a beautiful sight. So for our spacecraft customer, that's kind of nice to be able to get that last look before GOES-T heads off into space.
That is now, it looks like all of the people that are walking with the mobile launch platform have on hard hats. Is that a hard hat area, I'm assuming?
Yeah, it's a personnel safety thing as the rocket is moving. That's the team we talked about that's following along, making sure that everything's working, making sure the rocket's good. But again, personnel safety, number one for us here, right, is to make sure nobody gets hurt. We want to protect that rocket, but we also want to protect our resources and our team. Our people are very important to make sure mission success happens. So just another precaution, using some hard hats and some PPE to make sure everybody's protected while they're working around that mobile launch platform and a moving rocket.
Now, is this an autonomous role, or is there someone actually controlling the caboose or the train that's pushing the mobile launch platform?
Yeah, so there are folks actually running the train trucks that are pushing the mobile launch platform to make sure they maintain the right speed and maintain the right timing to get this thing up to where it needs to be. So the team will continue to move that up, and it's important that everybody's in sync with that. So as we said, the team that's running in front, they're checking things, they're making sure all the systems look good on the ground here, and the rocket is looking good. The team in the back is continuing to work that, and then there's also a launch control team in the LCC watching telemetry, maintaining or making sure that everything looks good from a wind perspective, a environments perspective, a vibration perspective. So it takes a big team to roll this thing to the pad to make sure we keep everything safe to make sure GOES-T arrives at the pad safely for launch tomorrow.
Now, I've seen this rollout many times, but every time I notice something different. There are people in the front of it with, it looks like it's a cable that they're kind of pulling back into the front of the mobile launch platform. Can you tell us what that is?
Yeah, that's a fiber optic cable that is being collected as they move up the pad. It's actually connected at the launch pad, attached to the launch pad to make sure that all the proper telemetry and everything is getting back to the LCC, right? Everything on the mobile launch platform right now is basically quote-unquote remote, operating on its own, either generator power or something else. But to get all the telemetry back to the LCC for the engineering team to evaluate, you got to have something do that. So we do that via a fiber optic cable that is connected at the pad and runs all the way down to the VIF. And then when this mobile launch platform transport comes up, this team picks that cable up and secures it, coiling it into that front box right there. And then when these go into the bat cave, that connection gets remade at the pad.
Wow, it is just pulling up on our position right here. And this never gets old. This absolutely never gets old. Just looking at the Atlas V just in front of us, it is just an amazing sight.
Yeah, absolutely, Franklin. I love this view right here. I am always amazed at seeing this rocket up close and the beauty of an Atlas V 5-meter fairing. This vehicle looks very good. GOES-T sitting on top, ready for launch tomorrow. I'm always excited to be out here.
Yes. All right, we just lost camera for just a second there, but the Atlas V is rolling right by our position right now. And Mick, this is looking good. They're on schedule right now, right?
Oh yeah, everything's looking really good. They are moving very well. Transport is going very, very good. Franklin, I can tell you, standing where we are right now, looking at this rocket is just amazing. Looking at those GEM 63 solids on the side of the first stage there, those look very nice. GOES-T looks very good, poised on top of this Atlas V here inside that fairing. United Launch Alliance has done a great job getting this vehicle ready, and we are headed to the pad, getting ready for launch tomorrow. The team is doing a great job this morning. They do have a lot of work. Once they get this to the pad, they'll still have to hook everything up, and then we will go into what we call RP1 tanking, rocket propellant 1 tanking. They'll put RP1 on the first stage and get it ready for tomorrow when we do cryogenic tanking at T-minus 2 hours. But they do have a lot of work to continue today once it gets to the pad.
So I'm not sure if everybody can see these white hoses that are coming from the trailer that's on the back of the mobile platform. They're kind of plugged into the bottom of the mobile platform. What are those tubes for?
So those are the ducts that come out of the environmental control system, or the ECS system. You can hear the air conditioning, or we can hear the air conditioning system right here, maintaining proper temperature and humidity air into the payload fairing. Those hoses hook into the mobile launch platform there at the bottom, and then there are pipes that go up the mobile launch platform mast, that big mast that goes up by the rocket that has the ULA logo on it. And then you can see coming across from the mast into the fairing more white hoses, and that gets all that air into the fairing to make sure the proper temperature and humidity is being maintained for the GOES-T satellite.
So how long is the process to turn over the mobile power to ground power as soon as the Atlas V reaches the pad.
So once they get it in there and get everything set down, they'll put the MLP in place, get it set down on the stanchions, and then they will begin the operations to transfer everything. And it'll take an hour or two, a couple hours to make sure that's done, and then they'll get ready for their next task, which is rocket propellant 1 tanking.
Okay. And how far in advance does that take place?
RP1 tanking, typically we will do that 24 hours ahead of launch or the day before, as we're doing today. The team will put RP1 on the first stage, and then when we come on station tomorrow for launch, the team will pick up the count and begin everything and get ready for cryogenic tanking, which is putting liquid oxygen and liquid hydrogen on the second stage and the first stage for launch tomorrow.
Now, why does that tanking take place closer to launch?
The cryogenic tanking takes place on launch day because of the boil-off rate, or as liquid is boiled off or evaporated. You want to make sure you're filling the tanks as close to launch as you can to get as much liquid oxygen and hydrogen into the tanks as possible. With rocket propellant 1 or RP1, which is like a high-grade kerosene, you can put that on board today and it can sit for days. So we'll do that now and then work to that cryogenic tanking so we can get the high-energy fuel on board for launch tomorrow.
Now, is the rocket going to move any further than it is right now, or is this a temporary holding position right now?
So this is a temporary holding position. What's happened is the P van and the G van, those two white vans in front, we are approaching the pad bat cave there that I talked about earlier, and the team is verifying everything, make sure clearances and all, the doors all, and then they will pick up the transport and move this into place. But when they are all done, the rocket and the MLP will actually sit in between all that white structure on the pad, which has the water system on board, or the water birds, and then they'll sit it down on the stanchions that are there at the pad. So right now they're in a temporary holding spot while they verify everything, and then they'll continue moving forward.
Got it. That was a question that came from my studio, but I'm going to get back to the tanking situation. After the 2-hour window has passed, if the Atlas V doesn't take off, is that cryogenic fuel extracted from the?
Yeah, so we call that the detanking process. And what we would do is if we don't launch tomorrow, if we scrub or the window expires because we can't fix something to get off tomorrow, to get the launch off tomorrow, the team will then detank the cryogenic tanks back into their storage tanks that are here at the pad, replenish those, and get ready for a launch on the next day. Typically a 24-hour recycle, depending on what issue we're working or what's happened. But yeah, we will try to recover as much of that cryogenic as we can to prep for the next day.
Again, the window is 2 hours for launch. How long days does NASA have to get this off the ground?
So we actually have quite a few days. The rocket can be ready several days after tomorrow. However, the problem we do have is resources and team members, right? We want to make sure we don't overwork our team. So we're currently set up for 3 launch attempts tomorrow and the next 2 days, and then we will need to reevaluate our timing and the launch team that's supporting to make sure that everybody's rested properly and ready to go. But right now we're set up for 3 launch attempts.
That is great. Well, Mick, it is great to be out here with you once again to view a rollout of the Atlas V, and we look forward to a successful GOES-T launch on tomorrow. The window starting at 4:35 Eastern time. You're going to be with Daryl Nail on NASA television, so we would ask everybody to please join in to view Mick with Daryl Nail on NASA TV tomorrow starting around 4 o'clock for the launch of GOES-T. Mick, it's been a great time hanging out with you today.
Yeah, Franklin, thank you. I'm always privileged to be out here with you guys on the NASA Edge team. Y'all do a great job covering these launches and everything NASA. Thanks for all you guys do.
Hey, it's not a problem. Hey, everybody, you're watching NASA Edge, an inside and outside look
of all things NASA.
At all things NASA.
At all things NASA.
Man, look, I'll give you a pass.
No, it's of all things NASA.